Alright, hi guys.
Hey y'all.
We're going to do a lesson today on factoring, or start the lessons on factoring, and we're going to focus today on the GCF, finding the GCF. Key terms for this lesson is going to be factoring, and what factoring means is that you're reversing the multiplication process, and you factor polynomials, obviously.
And so when we say reverse the multiplication, if you have a binomial, let's say x plus 1 and 2x minus 3, we've learned how to multiply this using the distributive or the box method. So factoring is the opposite, when you have your answer and you put it back into two parentheses.
Alright, and then GCF, which is the abbreviation for greatest common factor. What this means is the largest factor that terms have in common, and we're going to show you how to find the GCF. Alright, so to find the GCF, you have to do, I kind of broke it down into steps. The first thing you want to do is list the prime factors of each term. And prime factors, as you remember from 6th or 5th grade, is your little factorization tree. I think that's how you learned it. So if you had 12, then the prime factors would be 3 times 4. And then you have to break 4 down into 2 times 2. So you want to break it down where it can't be multiplied by anything but 1. Second step, once you break down the prime factors for each term, you're going to circle all the factors that they have in common. Then you're going to pull out all the factors and multiply them, and all your leftovers are going to go back in the parentheses. So we're going to do example 1.
So our first example is 12x cubed plus 18x squared minus 15x. This is a trinomial, and the only thing we want to do, we can't add or subtract to them because they don't have like terms. It's not a multiplication problem. So the directions are find the greatest common factor. We are going to look for a common factor.
Alright, so let's break down 12x to the third. 12 breaks down into 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. And then x to the third power is x times x times x.
Alright, 18x squared. If you need to, do a factor tree. So 18 could be 3 times 6. 3 is prime, so we break 6 down to 2 times 3. So the prime factors of 18 are 2 times 3 times 3. And then because it's x squared, that means x times x.
Alright, and then last 15, we break that down, that's just 5 times 3. And both 5 and 3 are already prime. So 5 times 3 times x. Alright? And then you want to circle all your factors that they have in common. So I see that every term has a 3. And every term has an x. So our GCF, if we pull it out, is 3 times x. Alright, so to finish the problem, to actually factor it out, you take the 3x out, and factoring really is almost, okay, that's fine, it's like dividing. So you're going to now take the 3x that you pulled out and divide all your terms, or since we wrote it out, you're going to rewrite your leftovers in the parentheses. So what's 2 times 2? And x times x leaves you, alright, plus, you have 2 times 3 and x left over, and minus, we only have 5 left over.
So that is step 4. All your leftovers, see these were not circled, go back in parentheses.
Okay. We want to make the connection because we don't want you to necessarily, once you get used to it, to have to write this down every time. If you look, you should eventually get to a place where you can look at all 3 terms, find the biggest number that goes into all 3, and the smallest variable, and pull that out. And then it's pretty much, if you look at it, 12 divided by 3 is 4, and 3 minus 1 is 2.
Alright, so example 1, 4x cubed plus 12x minus 8x. Is that supposed to be x squared? Okay, 12x squared. So like we did before, we are going to write the prime factors of each term out. We already know that 12, let's just start with 12, was 2 times 2 times 3, and then there are 2 x's, x squared.
Alright, and 4x to the third is easy. You guys know that 4 is 2 times 2 times x times x times x. And then 8 would be 2 times 2 times 2 times x. And Ms. Hintler is going to circle what they have in common.
So they all have a 2 in common, and they all actually have another 2 in common, and they all have an x in common.
Alright, so we're going to multiply together what they have in common. 2 times 2 is
4.
4, and then an x. So that's the GCF that you have pulled out. You factored it out. And then on the inside, you're going to leave what's left over for each term. So for the first term, what do we have left over?
We have x squared.
So x times x is x squared plus.
For the second term, we have a 3 and an x. So you multiply.
3 times x is 3x.
And then for the last term, we have a 2 left over.
Minus 2. So we have factored the GCF out and written in parentheses what we have left over.
So for number 2, we have only 2 terms, and we need to write the prime factors of. If you look at it though, I think this one you should be able to start to do this mentally. 5 and 10. Let's just look at 5 and 10. What is the greatest common factor of 5 and 10? What's the largest number that will go into both 5 and 10? And hopefully you're thinking 5. So the first one would be 5 and 3 D's. And then, let's just one.
Alright, and so, like Ms. Handler said, you should be able to, once you do enough of writing them out individually, you're looking at the number first to find the greatest number, but when we talk about variables, it's actually the smallest amount for the exponent. So we have a D in both terms, so we know what D needs to come out, but we only can pull out one D because this one has an exponent of 1. So then our parentheses is, well, what do we have left over? Well, what goes, that would be 2 D's left over, 5 and 5 is 1, minus 2, because 10 divided by 5 is 2.
So we have found this is the greatest common factor is 5D. And then we've shown you what to do with everything else you haven't used.
Alright, so number 3, we have a squared, we have 12a, and we have 30. So we're going to break these down. Everyone sees a squared is a times a. 12 would be 2 times 2 times 3 times a. And 30 is 3 times 2 times 5. Alright, so what do all 3 of them have in common?
So first you look at the numbers. A squared doesn't have any numbers, so they don't have any constant numbers in common. So then we look at the variables. We have 2 A's, we have an A, but down here we don't have any A's. So they actually don't have any variables in common.
So when you have nothing in common that you can't pull out that all 3 have, that's called prime. And the definition of prime means it cannot be factored. Not factorable. Is that word?
Yeah, not factorable.
Non-factorable? Not. I don't know. It can't be factored. Okay? So we write our answer would actually be the word prime. So this is the last example. 3x to the third and 15x. And we're going to do the same process again. 3 is already prime, so 3 times x times x times x. 12, again, is 2 times 2 times 3 times x times x. And 15 is 3, didn't we already do that? Oh, we did 18. Okay, sorry. Seems like the same problem over and over. Alright, so let's see if we have numbers in common for all three. I see the number 3 in all three, and then an X in all three, and I think that's it. So that means 3 times X is our GCF, so we pull that out. That's 3X. And we write down what remains. For the first term, we have X times X, which is X squared. For the middle term, put the sign that was there originally. You have 2 times 2, which is 4, and an X. And for the last term, we just have 5. Now, before we stop the video, just want to remind you that you can always check your work by multiplying. Remember, factoring is the opposite of multiplying. So if you're unsure of your answer, if we multiply using the distributive property, this answer back out, we should get the original problem. So 3x times x squared is 3x to the third power. 3x times negative 4x is negative 12x squared. 3x times 5 is 15x. That is our original problem, which means our answer was correct. We will definitely practice in class on Friday.